I'd like to thank Software Mill for putting this all together. And I know it's been a long day, so maybe I'll finish up a few minutes early for everyone. But appreciate the time to kind of talk through a few things. The presentation is actually a DocuSource site, and all the code's been published to a GitHub repo, so you could actually just go ahead and download the presentation as well as all the source code, which shockingly works. And so everything that you see here is something that's running. So I want to talk about full stack a little bit, and I know that the concept of full stack is a little bit vague these days. You know, when you kind of start thinking about what full stack means, it used to mean, hey, there's a front end and a back end, and there's kind of like two parts. But you know, really, full stack today means a wide range of architectures, because there's a whole bunch of things in the middles. You know, there could be services, there could be lots of back ends. Front ends, there's usually 3 or 4 front ends that you need to go feed. So full stack is just a way to kind of say, hey, we'll talk about things in the user interface and then things that are not in the user interface, so to speak. You know, when you talk about doing a full stack effort and having to put all these pieces together, there's a lot of factors that go into a decision about whether you need to, you know, what technologies and what type of choices that you might make. For example, you know, whether the labor is available with certain types of technology experience, what's actually been proven to work. So if you're in corporate America or corporate, you know, world, you know, proof points are really important. Your deployment targets, audiences, time to market, and cost are all kind of key thoughts to making sure that that you make the right choice. And really, when it comes down to it, the economic thinking is really the way that a lot of decisions are made. So, you know, for example, the current economic thinking, which is really kind of business thinking, is what's my time to market, what's my cost, and is it good enough? The good enough mantra is to some engineers, you know, sort of a bane, because good enough just means, hey, we need to get the job done, and we need to move on to other things like making money and things like that. And so sometimes good enough says that you can't use some of the newest technologies. Sometimes you have to work with some old stuff. Sometimes you get a little bit of new stuff. Sometimes you can go totally greenfield. Lots of things kind of go into this concept of good enough. And, you know, when you start thinking about what might be good enough, programming languages are a small factor in some of these economic decisions about what to do with your full stack. So for example, if there's a programming language in a library that solves your problem, then you're going to probably go with that pretty quickly. For example, Google, and my background's machine learning and you know, big data things and blockchain stuff and stuff like that. But you know, Google's putting out some new programming languages for machine learning. They're going with Swift in a very big way, because Python has some problems, and pretty soon there'll be a whole bunch of Swift programmers doing AI type work just because the libraries will be there and things like that. So you know, if you're tying into an existing project, you're really going to have to use some technologies that fit into that project, and you don't always have the luxury of something that's greenfield. And I encounter this a lot when doing some very novel things on the back end around, you know, sort of smart powered decision making and smart information. But the front ends might be using some more traditional technology and stuff. So, you know, when we think about full stack, we were kind of thinking about apps. We have sort of deployment targets, mobile, browser, native desktop, and popular choices that kind of go into that. You know, for example, if you're looking at the browsers, HTML, CSS, and JavaScript, there's 3 or 4 different major deployment models and architectures that you would use for that. And then on the server side, you know, there is, you know, infinite number of frameworks and libraries that you can use, and programming languages and things that you probably don't even know exist or even worry about that need to be in place in order to build that full stack. A popular choice for certain types of problems is to deploy to the browser using Typescript with some type of SPA application, a single page application. And to have a server, if you're not sort of Facebook size scale, you might do a nodejs server with Express and GraphQL, which is very popular for a lot of good reasons today. And that might be enough to solve your problem and to give you the range of scalability that you need. So it turns out that a lot of these programming languages and tools and frameworks are fairly easy to pick up and start moving with. Maybe they don't solve the problem in the way that we'd like to, but they're good enough to actually help people make money. So, JavaScript and some of these JavaScript-based tools are super popular. And then you start thinking about, how do I scale these, both the user interface as well as the back end? If you think about the back end for a moment, you have a different scaling options. If you're going with this JavaScript-based stack, you can actually just run more of those node processes running your JavaScript. You can run more than one process on more than one server. You can then start going into microservices and query federation and gateway patterns and things like that, so that that little node process isn't doing as much, or you're able to go back efficiently. And then you have some new options that are coming up, especially around, when talking about Node, for example, Growl allows you to actually stick a JVM directly attached to the executing code for Node, and it does it in a new way that they've kind of rewritten Node, so to speak. And you're actually able to attach a JVM backend to a, when I say backend, it's the backend of the server process. You can attach a JVM process like Scala running with lots of threads and doing lots of cool things, and attach that to a Node.js web server that already exists. And so from a perspective of economic scaling, you have choices of how to actually scale out, and they all have different price points and costs and issues associated with it. So, that's good that you have a lot more options these days, and that makes it nice. So let's go through some assumptions here about what we're going to look at. First, from a management convincing perspective, you need to have some speaking points to try to say, hey, Scala is a useful choice for creating the full stack and for enhancing what we have and sort of being economic about iterations and doing things. And so from that perspective, you can always try to use some speaking points to tell a story. Some of these are not quantitative, but you can talk about leveraging skills. You can talk about maintenance costs, and you can say, hey, some functional programming seems to be better from a maintenance perspective, and Scala has a lot of this stuff already built in, makes it easy to use. You could also say that the current application is not economic to rewrite, because usually it's not economic to rewrite an entire application or something large unless you have a significant budget or there's a significant requirements issue associated with it. So getting that type of big dollar spend to do something greenfield is very difficult. You may also just encounter folks that say, hey, I'm a new manager. I've had some bad experiences with TypeScript and JavaScript projects. Maybe we can start doing something a little bit different. Scala might be a good choice for that. So, the idea of gradual adoption and the full stack and Scala.js kind of all fit together as a way to kind of start introducing some Scala technology into these different parts and projects that you might have, versus just having it run in the back end and do large lifting on information management with tons of threads and really cool containers running everywhere. You might be able to start using Scala in a whole bunch of places, and Scala.js in particular. The application we're just going to look at for the next few minutes is really a very simple, contrived web client, which is a SPA application. And it was the base of it that's on the GitHub repo is in TypeScript, and we want to integrate into that. And the other idea is we're going to have a little server going, and that server is going to be a Node.js server with a GraphQL, which is very popular for data services. It's also written in TypeScript, and you can see that we're going to stick or Scala.js into each of those parts, and we'll talk about the config issues that you need to worry about. We're not going to have a real database for this little app, and that's because we want to keep it tiny. And in fact, here's a picture of the application itself that is in this GitHub repo. You can look through a list of books. You can click through and look at the authors, and you can click on the authors and go to the people, and then go to the books and navigate around that graph of data. So this is the app. And as I was clicking through it, you probably, of course, and should never expect to know what technology is actually running it. but half of this app is actually running Scala.js, and the other half is running TypeScript and JavaScript type libraries. So that type of interop requires a lot of config. Config is always hard. And in a mixed project, it makes the project a little bit harder. But fortunately, if you have an existing project that you're targeting, because it's not a greenfield, for example, you have an opportunity to actually use a slice of Scala.js to get everybody kind of familiar and used to it in a very low risk way. And I'm actually just going to show that in the app because we slice into the backend server a single function that's a resolver for GraphQL. And you'll see that it looks very compact and useful, and it's just a way to think about and show how it's a very non-intrusive, and it's something that maybe can have legs and use more Scala in other parts of the organization as well as these full stack projects. So interop is hard. I don't have to say that too many times because I think we've all suffered from that. Anytime we have interop, we have code generation, we have interop libraries. It's all very difficult. If you can just use one tool, one language, one something, and solve the problem, you should stick with that. That's almost always going to be better if you can. But like I said, sometimes you have issues and you need to think a little bit outside the box to start solving that. So here we can see that for the client server and the Scala parts of the project, we're going to generate that Scala.js artifact, and we're going to place it into these other projects. The GitHub repo has been created like a real project you would encounter, which is the client and the server are completely separate projects. The Scala part is a single project that has both the front end and the back end code being generated, and then it's placed into these other projects to be consumed as a pure JavaScript artifact. So we're going to go through that and just take a quick look. All right. So we talked about GraphQL. Just real quick, GraphQL has a schema. This is a very simple schema. We talked about the books and the authors on the application as we click through this application and showed an example. And so here we have a thing where you can get all the books or a single book and all the authors and a single author. And I won't tell you which one's in Scala.js, but half of that again is actually in Scala. And then you got the book type and the author type, and you can have enums and all that type of good stuff. The hardest part of creating a GraphQL application and where types are hopefully more useful is not so much in creating just a type that's a author or a book, but it's actually making sure that your graph resolves correctly into completion for all the data that you're requesting. And when you stitch together these graphs from a lot of places, for example, you could actually federate out your GraphQL, which is becoming more common. You have to try to make sure that you can prove that you're actually going to get all the data that you think you can. And that's why you write tests and stuff, but it'd be nice if we can statically prove that. Projects like Caliban, which is based on ZIO and going after a code first model, helps you work through that, as well as having very thorough graph generators or code generators and other tools and things like that can help. But that really is the hardest problem of these GraphQL applications. The database itself is totally static out of JSON, not allowing writes in the demo application. And you can see that we have a book type and something from a database for the database author. The types look close, but they're not exactly the same. GraphQL is not going to be the same as your database, of course, your schema. So you have a little bit of friction between the two. And here we just have a few data points that are in there. So that's our GraphQL schema. And the question is how do we start tying into that and starting to have the interop that we're looking for. So let's go through the config, and this will drive the interop config that we need to have in order to slice Scala.js into the different parts. You can create a GraphQL server very quickly in just a few lines, and you have to add some resolvers and queries, mutations. This is all GraphQL language. But here's some code right here that actually sets that up. So here you have the topmost query where you can actually ask for some books or some authors. And then you have resolvers, which, again, these are sort of subparts of the graph that help with the data management aspect, where it fills in the gaps from the top line queries. And again, you think about a data object going over the graph, getting filled in with little bits and pieces, resolving these little fields as you go. You can imagine there's a lot of different strategies for doing that. It becomes quite complex. Here are some resolvers. For example, you got to resolve these top queries. You have to resolve fields inside of a book, and you have to resolve fields inside of an author object. And that's actually where we put the Scala.js part for the server. You can see that we've done, this is all TypeScript code right here. Now we've actually just kind of said we're going to load the Scala server part just like a standard JavaScript module. We're going to call require because this is nodejs, so we use require instead of import. And we're going to bring in the Scala server part, and we're going to then reference these properties which have the resolvers on them. And then, of course, the rest of the config is pretty straightforward. You have some loaders and things like that per request in your context. So we can see that we're going to look at the author, and that's where the Scala.js is going to come into. So let's just go ahead, start looking and drilling down into that. We talked about the GraphQL, and the approach that the server takes is really a schema first versus, say, the Caliban code first approach. And so there's a code gen tool for GraphQL that's quite popular called GraphQL Code Gen, not a surprising name. They have lots of TypeScript support. They also have, Reason support for Reason React. They have support for Java and a few other languages. And I've written a code generator for Scala that does some very simple code generation. It's not super sophisticated, but we can use GraphQL to generate the types for TypeScript for the TypeScript parts of the server. And this is what you often see. And if this looks really messy and there's like lots of types in here and it's a little bit confusing, I agree. In fact, when you start highlighting some of these types and you start looking at them or get errors, I mean, the error messages are just brutal to read through. I know a lot of people talk about Scala and some of the difficulty of reading error messages and using the tools and things like that. But in the JavaScript world, what I found painfully is that it's like sometimes worse than what we have in the Scala world. In fact, if you look at these types and you look at the errors that come out of it, and, I'm thinking at times like, this is really hard. You got to stare at it for a few minutes just to figure out where the line breaks are in the error messages. So it's, crazy stuff like that. But you have to code generate the TypeScript parts, and then you have to write the resolvers. Again, this is in TypeScript. We're going to get to the Scala part here in a second. So what you need to do is you write down your query resolvers coming from these types for getting all the books, and then for a specific book. And then you need to resolve, say, the authors field in this case. And there's some logic and some loaders and caching to help make that more efficient, but probably not the critical part of the conversation. Now, for the author part, which is where we're going to have some Scala, we can actually write, and this is where we're going to finally slice Scala into it. And think about, we could slice a big chunk of Scala into here, but maybe we just need a quick slice. Maybe it's an opportunity to show how things can work. So here's the author resolver. So you can, get, for example, all the authors or a single author. But we've not actually provided the resolvers. Since this is authors, you want to resolve, say, the books that the authors have written. So we probably need a resolver that resolves the books, just like when we were up here, we saw a resolver that resolved the authors given a book. So given an author, we need the books. And that's where we have an opportunity to use Scala. So here we have a opportunity to insert this little slice. But now we need some more interop. We've generated some types for TypeScript to use from the schema. So we also need to access resources in the server project that are not related to GraphQL, like repos and data accessors and different functions that do clever things. And here we're using scalably typed. And what that does is it actually takes a project like a TypeScript project that you might have sitting in your directory, and it'll actually generate all of the Scala code for it, plus all the dependency packages that it finds. So you have a complete closed graph of types here. And it works quite well. It's not perfect, but it works quite well. And it removes the need to actually create a lot of interface files for potentially very large surface areas of API that you might need to use in Scala. So this is a very high productivity tool. It makes it quite easy to use. You can see that in this particular one, we need to go and get some types and some repos in order to write that resolver. This is coming from Scalably typed directly. And so you can see that it has a top level package of typings, and we actually just called the project Scala, so it's Scala stick there. And you can see that there's a string in here, which is an import statement. And the one thing we know about JavaScript environments is that you see a string, you should panic because you know that's going to be some type of file system string that you have to make sure is resolved at the proper level of whether it's relative to something or an absolute file path. In this case, you can see there's a path in here. It's the way it needs to be. The code looks very clean and quite nicely generated. But you have to, anytime you see like a little string like this, the key thing for Interop with Scala.js is that since it's JavaScript, you have to do exactly the same thing that you do for JavaScript projects, which is pay attention to your paths, because package resolution or module resolution is all based on file system, unlike the JVM. And this causes enormous amounts of confusion because you must envision where that string is going to be called and a package loaded at runtime. And so you have to arrange for all these paths to line up. This is the single hardest problem in the Interop, is to figure out how all this stuff really works. So it turns out that once you do that, you may need to actually create some resolution paths for your project. So for example, you can create a simple link to make it look like this is a standard module in your system because it looks like it is a top-level module, which will resolve to node modules. So you do some linkages trick. This is all part of the Interop pain and suffering that you need to go through. The Scala part's actually quite trivial at this point. We saw that we had a GraphQL schema. We actually generated some TypeScript for it. We wrote some TypeScript server code. And then we actually took the TypeScript server code and generated Scala.js. So there's actually a couple levels of code generation going on. That could be a source of confusion, but this is actually the resolver. What you'll notice is if you take out all the comments on here to try to explain things, there's only 3 or 4 lines of code for the exact TypeScript, which was only 3 or 4 lines of code. We're using nominal typing here versus kind of that structural typing. So you see these big type names. It's a little bit not too scary, and we see the imports that we have that we'd have to lift a finger for. And from a server perspective, we can write code like this all day. One thing I'll point out is that if you're a Scala developer, you like to use map and flat map. The repo find all returns a JS promise, but we're mapping into it. Usually with a JavaScript promise, you have to use then. Some very simple extension methods on JS promise makes it look like future. You don't have to convert to future. There's no future conversion here. You can keep your code very clean, and you can use Scala like method calls on here for that type of effect. Future is a decent effect for doing a few things. If it gets more complicated and you have more sources and you got to integrate more, you're definitely going to want to use, like Zio, for example, in the last talk, which is a great talk. And you'd use Zio for Scala.js, and that might help you tame the issues around asynchronous and concurrency, even though you're not parallel. So that's sort of a nice thing, which is you can tap into the ecosystem, and on the server side, it doesn't matter how much code you bring in; it's all running on a big server, so you don't have to worry about how much kilobytes of code you need to, like you would on the client. So that makes it pretty easy. And so overall, when you need to combine several actions at once, unlike the 3 or 4 lines of the repo there, the FP things start making sense. You can scale up complexity by adding extension methods to promise, make it look like a Scala feature without having to convert to a Scala feature. That keeps it easy, especially if you're a TypeScript programmer coming over to Scala, for example. And then you can also tap into the big old ecosystem of effects that exist out there. So that's the server side. We sliced in, and the key thought is we sliced in a very small function. We had a very minimal impact on the actual application. And we were able to do it with some config, which you have to kind of squint at for a while, but it was actually quite straightforward. Let's just talk about the web client real quick. The web client we saw was basically this application. And we saw that the server had a little bit of Scala.js in it to produce some of the author information. For example, the names of the books that an individual author had. So this list right here is coming from Scala on the back end. Now, there's a lot of frameworks for writing clients these days, especially for the web, like React or Angular. The choice here is React. I use that a lot, not because I am a UI guy. In fact, I'm probably the furthest from it. I only care about the UI because it serves up the information from my backend with all the smarts from the AI and machine learning, et cetera. But if you're writing a corporate application or you're just trying to get something done, React is a huge ecosystem, and it's just getting larger. I think it's just going to consume the world at some point until the next thing comes along next week, and then something else will consume the world. But to integrate it in, we have a single Scala project, and we've already served up a little piece to the backend. We can also just create another little sub project in the Scala project that serves up the front end. And all it needs to do is output a Scala.js artifact, which is a JavaScript module, and literally copy it over to the JavaScript front end project, and it'll just absorb it in just like any other module there. So conceptually, super easy. We have to worry about these paths and things like that. We also have to worry about size. So if you're integrating into an existing web application, you need to understand bundle sizes because you're going to be given a budget for size. The Scala.js output can be large because it brings in the Scala standard library and other things if you start using the Scala ecosystem. So you got to find the balance there. For example, bringing in cats and other things, and even ZIO can blow your kilobyte budget on the front end. And even with some clever tree shakers and things like that, it may be too much. So you need to kind of find that balance about what libraries you use, and then how much they're weighing in terms of your budget. And it's my perspective these days is that I don't go to those bigger libraries, even if they're helpful, until you have some pain and suffering, because you're going to be paying on the front end with load times and things like that. So let's go ahead and just configure what we need to do. If we're using Scala, and we're going to output a Scala.js module, a pure JavaScript module, then all we need to do is use some type of bundling process to include it in the main web application. And if your main web application is using Webpack, for example, you just need to say, hey, there's a Scala.js file. You could use the normal processor, but it's not always best to do that because it's already been specially processed by Scala.js compiler. There's a loader, source map loader, that's a little bit more friendly to source maps and things like that you can use. And the idea is that it's literally just another JavaScript module. You can see that it's called, in this case, Scala.js. What I typically do is rename, whether it's the optimized version or unoptimized version, all the same artifact name. That's the way these large TypeScript projects and JavaScript projects like it. So they just have one name. You don't have to worry about fast or optimize, etc. So you can normalize the name real quick. You always output the same thing, picks it up quite magically, and incorporate it as a module. And at that point, you have to ask yourself, how do you incorporate that in on the TypeScript side? Because Scala does not actually, create a description, a TypeScript description of your project. And at the same time, inside of your module that you're writing, your Scala code, you have to access other services that are being bundled as part of the main TypeScript program. You only have a couple ways to do that. You can type in the facade, or you can use scalably type like we saw for the server. And I find that sometimes a combination of both works best. And you have these different ways that you can access the packages and information that's actually already there. And that's an important aspect of kind of tying into what exists. You're not disrupting and forcing massive change on people. What you're instead doing is actually blending in super nicely and not disrupting the main effort. So that's a critical aspect of kind of working with the existing teams and doing the right thing. So once we have that, we can then make sure that we're integrating to the JavaScript build, and we have to go through that. We're going to co-locate, for example, our Scala project maybe in the same repo as the front end. We're going to copy that file over. We need to access some of the types using these facades. And we also need to access the GraphQL information that's also being used by the front-end application. So GraphQL needs to be code generated for the server. And then in this case, if you're going schema first, you need to generate some GraphQL for Scala.js. Scalably type can actually absorb some of that, but the types get, as we'll show, is super complex. And sometimes a very direct GraphQL to SCALA.JS generator is good. There's actually one built into Apollo for Slinky, and Slinky is another React facade for Scala.js. I used another one here, but it's another choice that you have. But we also I put together a little code gen for GraphQL code gen that generates Scala code. And here's the config for it. So now you have another config file you have to manage. You can see that we've embedded, basically paths directly into here. And so we see these more paths coming in where we have to really manage where we are in the file system as we do the build. Very standard interop and config work, but it can be a lot of work. And if you start moving things around, maybe a configuration library like doll or something like that, where it's sort of a programming language that's helpful for configuration, maybe that or templates might be useful. So we have some of these config things that we need to worry about. We have to keep an eye on it. There's additional considerations that you need to have around things like routing. You may need to pick up config information from the Typescript part of the project in order to create routes and things like that. My tip there is, after having gone through it, is embrace the complexity of that and don't think that it's going to be trivial or easy. The JavaScript world, or excuse me, the Java and JVM world kind of make these pathing things a little bit easier to manage in some ways. You still have jar issues, but you really have to embrace the idea that you have to kind of work through this and know the details. All right, let's just go to the Scala web client real quick. So we talked about React as the framework. There's lots of things you can do around React. It's evolving all the time. There's lots of state management frameworks you might need to tap into because they pre-exist on the TypeScript side of the application. And these things are just evolving at enormous speeds. In fact, there was just a new state management library that came out yesterday called Recoil, which looks pretty good. It's a little different than everything else, and maybe it's something that people need to use. But you have all these choices; you got to tap into them. Just real quick for React, so when I show you the code, it makes sense. In React, a component, forget about things like class components, but a component is just a function. It looks like the function that you can see that I just highlighted down there. They also have things called hooks, which is some reuse around state management, and it ties into the React runtime. And then there's some new things that have come out around React Concurrent, which isn't really parallel, but it allows you to prioritize rendering. But the way to think about it is a component's just a function. It takes an object like a props, and then it does a whole bunch of back-end jumbly stuff, which is not pure and very confusing and uses lots of hooks and causes people no end of suffering. And then there's some pure rendering code, which is given all the information from here. You can actually just generate some, essentially some virtual DOM, but it looks like HTML. And that's the short answer for creating a component. It's that easy, which is it's a function that takes an object that has some props, and then there's a bunch of stuff inside the function. Not to cause too much confusion, but this is the way you see it written in TypeScript a lot. And in reality, those little brackets just get turned into a function call. And then that function call actually just returns a data structure. And it turns out that all of React, in the way that's constructed, is to separate out execution from values. And in fact, React is very functional in that sense, even though people don't talk about it that way. But essentially, when you create these elements from the components, you're creating a value, and then the runtime system actually executes the value to cause the rendering to occur. So it turns out that all of this is very functionally thinking, but it can be very confusing because of the way people talk about it. But in general, that's actually all that React really is doing. Here's some TypeScript code for doing the all books. So if we go to the app, we type in books, there's a list, and then it says all books, and there's the books page. So there's a little bit of a layout and a template. Here's the way that we generate the list. So again, this function is a component. There it is. We're going to bring in some of the information that was generated from GraphQL for TypeScript, and we bring that in through the generated path. And then we have this list. This is using the Fluent UI library from Microsoft, which gives it the look and feel. So there's a shimmered list. So as it's loading, it shimmers, and then it has a few columns, and we render a link and stuff like that. All that code is pretty short and straightforward. If we go to the Scala.js side, this is the code we would need to write. There's a library called SCALA.JS reaction. This is a library that says, hey, if a component's just a function, let's keep it that easy. And we'll just write a type alias for it, and that's a component. That's all you need to do for using the SCALA.JS reaction facade. Here's the all authors. The previous one was all books. And there's a little bit of ceremony around accessing some of the Apollo information, but we have that just in a couple lines up there. There's the props. Here's a function that says apply. So this is the all authors component. And when we call it apply the props. And then the actual component itself is just a function. React FC we saw was a type alias to a JavaScript function inside of Scala.js. We can export it without any extra work just by using standard Scala.js, all authors. That means that this Scala module, when created by the Scala compiler, at the top level will look like it has an export that says all authors, which is a component. So that's all you need to do to export a component to Typescript. And you can see that the component looks almost exactly the same as the other one. It's about as compact, maybe a couple extra lines, and looks very Scala-ish right here. And that's all you need to do for that. But on the TypeScript side, there's no magic for generating TypeScript definitions from Scala yet. So you have to write a little bit of interface. This is the actual interface for 3 components. And this is written in TypeScript. And so you put this into the TypeScript project. And it says, hey, there was an all authors component. And it has a props that takes a class name argument, and that's all you need to do to import it. If you had more complicated stuff, you have to add it, but that export statement and this little config file, so to speak, for importing in a TypeScript is actually all you need. So you can see that the amount of information you need, the amount of config you need, is actually not huge, and you have to be careful about those paths. And I have known the problems with those paths because I'm never careful about them until they cause some error and I have to go track it down. But you can see the actual interop and slicing just pieces of Scala into the application is quite easy. We also see that the authors, the all authors page, the individual author page, as well as the layout, the page itself, the page layout, that's all written in Scala.js. So in this case, maybe there's already a books tab, and that was written by the TypeScript guys, and then it said, come over here and let's add a new tab that has authors in it, because it's going to be really cool. People want that. Potentially you could do that with Scala.js. And you saw that other than writing an interface file and then making sure that you've can tap into the existing TypeScript infrastructure for the web application, for example, writing some facades manually or automatically from scalably typed, you can do the interface and the interop with the client side. So that's all good and wonderful. Just a real quick note, this is actually a quick comment that I wanted to make, which is we talked about how you have different factors that go into a decision about whether to enhance an existing application. These could be opportunities for Scala.js. But you can also do other things now. You can, instead of scaling out with containers and servers and, running more processes on the same server, you might be able to scale up. And the scaling up would look like using, for example, Growl. This is all kind of a little bit newish and not proven yet, so it needs a lot more baking time. But Growl has a node server that has a JVM under it. You can actually have JVM code running. And there's some issues around performance and load times and things like that. They're all being worked out, but it's actually quite encouraging. For example, you could take dotty, and you can write a little dotty program. And if you use dotty, you get extension methods on this Growl value object. Growl value objects coming from the JavaScript world, and it's the interop value. And so you have an opportunity to say, oh, I'll use dotty to write some extension methods. And then I could just write my resolver using, sort of the JVM language of your choice. This is actually not the full resolver. I just mocked this up, and it actually runs a course. But you need to pass in the args, which in this case, if you're looking to get the books for a specific author, just like we wrote in Scala.js, you would look at the args object. You would pull out the ID if it's there. And then you would resolve it using some repo. And in this case, I returned a string because I was super lazy and said, hey, it's a list of books. But that's how you'd write the resolver. what's nice about this is since you're on the JVM side, and because this interop concept of the value comes into play, you can pass these values back and forth. You can actually take JVM objects and pass it back into node, in this case, a Growl node, and it can access those objects directly. You can actually access data coming in. You can call functions either way. It's actually kind of sweet from that perspective. And that makes it nice. In fact, if you go out and check out this project, you can actually run this. I ran this by hand just to run the test, but the idea here is that you can dump out the class path. You can, this is all, again, just kind of to run the test here. If you dump out the class path, and you can just run node using the JVM or the Growl version of it, kind of using this this command, or you can make a command inside of SBT to run it directly as well. And then what you have is all of a sudden you have the ability to run your server code in the Growl node part unchanged. And then you can actually add a few lines in, just like kind of we did for the Scala.js version, and run the resolvers coming from the JVM. And in fact, here's a little proof that it works by running node. And now you can hook up ZIO and other JVM tools to it, and you can scale up instead of out. And so you have some more options, again, for taking this existing application, slicing in Scala artifacts and technology, and making life a little bit better for some of the devs who want to do that. So from a full stack perspective, you know, we really have choices now, and some of these are quite economic. Like I said, it's very difficult to get funding to rewrite something, especially if it's large. It can take a year or two to get that funding. Typically, I'm involved in projects that are $10 to $20 million with several work streams, and are quite complex. And you have to make all these kind of choices all the time. You want to try to keep it easy. In the JavaScript world, nothing is really easy. So you have an opportunity to bring into that noisy environment things like this that maybe take over the entire stack. And at some point, it's all Java at some point, right? So that's kind of the story. Just as a recap, slice into the back end and the front end. It doesn't have to be extreme. You can rewrite the whole part if you get the budget for it. The config task can become complex, but it's not extensively hard. And if there's an existing project you're going into, there's a config there already, so that just makes it a lot easier. And you really have to embrace the complexity of the configuration. It really wasn't that hard for this project. It can be harder for others, especially for code generating gRPC and protobuf and 10 other things that need to go into your project. But really getting that config to work just takes a bit of time, and you have to pay attention to it, which is always hard to do. Using a simple platform like nodejs, it's an easy way to program. What I found is, shockingly, because I'm used to really large, complex systems that are crazy, insane, that often don't work, and the operating systems are broken and things like that. I won't tell you about the painful past of the massively parallel world that I used to harbor in, but the JavaScript platforms are kind of easy. You got some concurrency, but it's not parallelism, and you can be very ergonomic in the APIs, and that just makes it really easy. And with JavaScript, which is just a super simple language, if you ignore all the bad parts, people pick it up really easy. They like it. It evolves. There's something new every day that gets people excited sometimes, and so a simple platform like Node.js, could be a good target, and to integrate some Scala into it. And then when it comes to parallelism, try to avoid it as much as possible until you actually need it. And then if you need it, you saw that, we have an option, for example, attaching some JVM code into an existing node. You didn't have to actually write it as a microservice. You didn't have to separate out the processes and go inter-process communication. You just attach it, use those values directly. That's a really great story for economically scaling up some existing applications. So from that perspective, that's really the presentation. The repo is available to right here, and I'll try to post it on the Slack channel. Again, I'd like to thank Software Mill for having me. I know it's a very late hour, and if you stayed with us this long, then it's very impressive that you guys all stayed awake from the beginning of the morning and all the talks. But thanks for the time to talk about some of this.